Hello and welcome to NOV Live. I'm Michael Gaines and glad you're joining us today as we continue our ongoing conversation, bringing technical expertise and experts to you as we talk through evolving technologies that are helping shape the energy world. So we're glad that you're going to be with us today as we dive down deep and talk about some emerging technologies in the world of cutters. So that'll definitely be interesting for those of you that are familiar with the space. And if you're not, this will be a great opportunity not only to learn about this space, but also get your questions in for today's experts. So speaking of today's experts, we have our own expert, of course, here who helps keep all the socials in line. So we have Shelby Dumaine, who will help us not only learn about the world of social and how you can be a part of it, but also our Rig Geek post of the week. So, hey, Shelby, good to see you.
Hey, Michael, it's great to see you as well. If you want to comment along with today's show and join the conversation and have your questions answered, the best way you can do that here, whether you're on Facebook, LinkedIn, or YouTube, is to simply comment below. I'm already seeing in the comments. We have people watching from Houston, Argentina, Colombia. Oh, I see Spain just came in. So if you're watching this, I'd love to see where you're tuning in from. And then at any point in the show, like I mentioned, if you have a question, go ahead and put it there. And we're going to get to as many of those audience questions as we can before we close out the show later today. So I really would like to hear from everybody. I look forward to seeing it. You never disappoint me. So I'm excited to see all those comments. And now I've been asking you to ask us these questions, but this is now the time of the week where I am going to ask you a question.
Rig Geeks Post of the Week.
All right, that's right. It's time for Rig Geeks. And I even see in the comments, I saw, looks like Larry is already asking, come on, what's the Rig Geek question this week? So very excited. If you haven't seen before the show, this is the portion where I ask you a question, trivia. It's going to be a little bit of a hint of what's coming up in the episode. And then at the end, we're going to reveal the answer. So if you think you know, go ahead and comment it. And like I said, we're going to see which of our Rig Geeks get it right. So this week, we're actually asking, and again, this is a little bit of a hint for the episode. We're going to show the question on screen. We're asking, what year was the Ion 3D chisel cutter first introduced by Reed Heikelog? So sometimes we ask a more technical, sometimes we're asking a trivia. Today's all trivia. How well do you know Reed Heikelog? What year was the Ion 3D chisel cutter first introduced by Reed Heikelog? If you think you know the year, bonus points if you even know the month or the date even. But if you think you know the year, comment it below, and we're going to see which of our Rig Geeks get it right at the end of the show.
All right, Shelby, sounds like a good one. Looking forward to that, and I guess we'll see you in the comments. So thank you so much.
See you there.
All right. Well, as we talked about just a moment ago, today's conversation revolves around some really innovative technology coming out of NOV's Reed Heikelog team. And we're going to be talking about the Ion Plus PDC Cutter technology. So to help us dive in deep and understand more about this, we have two experts with us today. We have Richard Rivera, who is the PDC Cutter Grade Engineering Manager, and Prabhakaran Centala, the PDC Shape Engineering Manager. So guys, thanks for joining us today.
Thank you for having us, Mike.
Thank you, Michael, for having us.
All right. Well, Richard, I'll go ahead and actually maybe start with you. So, I know that as many have seen in every industry, of course, we have impacts of COVID-19, and of course, it challenges all segments of oil and gas. Specifically, kind of maybe diving into the Reed Heikelog team. How have you all continued to manage and work through those challenges?
Yeah. For one, like most oil and gas companies or businesses within the oil and gas segment, while times are good, you have to prepare for times that are bad because it's a cyclical industry. And lucky for us, Reed Heikelog management has seen the value in PDC cutter technology, and they continue to invest even in uncertain times like today. And they continue to invest in our people, our projects, and also our equipment. Hundreds of thousands of dollars and even more than $1 million, at times. But that continued investment is allowing us to continue to have breakthroughs and commercialized products. We just launched Ion Plus 2 weeks ago, and this is coming, out of a down market, right? Really down market, and historically down market. And we're proud that our management team has invested in us and has helped us get this technology to market. Just to give you a little bit of background about other products that we've launched recently, we had in Q4 the Ion Alpha commercialized, as well as in 2020, and then in Q3 of 2020 we also had the 4D cutter shape family. So it's just a show of how much our management is invested in the PDC technology team here. So we're very proud of that, and that's how Reed Hycalog is managing through these uncertain times.
Right. No, well, that's good to hear for sure. Maybe a quick follow-up for you. I know that you and the team have really worked together and put in some long hours and late nights, I'm sure, as you recently came out with the Ion Plus product launch. So wanted to maybe talk about that a little bit. I know some folks, actually a lot of folks, follow the LinkedIn page, the Reed Hycalog LinkedIn page, and the NOV page. But for those that may have missed it, can you talk a little bit about that and help us understand, what really sets the Ion Plus product offering apart from other offerings?
Yeah, it's definitely the major difference in Ion Plus to Ion is that it's a step change in performance. So what we're seeing is complete differentiation within the field performances. So that's a major difference. First, it's seen, of course, in lab testing, but there's some differences where we have higher pressure manufacturing processes that it improves on toughness and abrasion resistance. But we also have thicker diamond tables where we're able to get more deeper leach and more thermal stability with that deeper leach, and also optimized profiles so that we don't compromise toughness. There are some similarities between Ion and Ion Plus. Again, reaching back, that performance is the key difference. But it does comprise of a range of cutter grades. And it also does come in our latest technology, shape cutter technology. Another thing that it's strongly based in is cutter forensic, which helps you select the right cutter grade for the right application, and also has a lot of design inputs when cutters are developed. So collecting PDC cutter forensics is a critical path to cutter development. As you can see here on the screen, over the last 8 years, we were able to increase thermal resistance by 360%. So that's quite significant. But really understanding the critical failure modes and collecting that data is part of the critical step. And then once you're there, then you can benchmark against that failure mode and then increase the performance like you saw there in the thermal. You see the same thing in the abrasion. In this case, we've increased abrasion resistance by 59% since 2016. But looking at these images, comparing Ion 2019 to Ion Plus 2020, that's a step change in performance there. And that's just only being seen in the lab. So, this is the idea behind the step changes, that performance differentiator. Then also when you look at impact resistance, comparing what we've done in the past to what we've are able to accomplish now, there's 103% increase in impact or toughness resistance over the last 8 years. So all in all, taking in the entire process of cutter forensics, benchmarking, and putting the best foot forward as far as Ion Plus goes, that's the biggest differentiator, is that step change in performance that you saw there.
So Richard, I'm a kind of a hybrid. I like numbers, but I'm also a words guy, and so I want to call out some words that you've been saying. Step change. So it's like, okay, pump the brakes. So I want to know, when you talk about step change, what does that mean? Like what metrics are behind step change when you use that phrase? Because I think of kind of one thing, but I know that obviously you mean something specific. So can we talk about that a little bit?
Yeah, absolutely. Showing pictures of the lab test is one thing, but really showing field data is really the bread and
Right.
butter, or proof of performance, if you will.
Right.
So yeah, we can queue up the graphic there. This is a 9 7/8 application, and right here in our backyard in East Texas, where it shows the Ion Plus run on the far left, and then you have two other wells drilled with 3 bits in each of those wells, or for this interval. And you can see that Ion Plus has basically changed a 3-bit interval into a single bit interval. And this is the type of step change performance that we're talking about. But if we look at this application a little bit more in detail, anything over 4,000 feet is going to see a severe dole. It's going to be a 4.3 all the way to 8.1, broken teeth. So quite significant severing of dole, right? This application is prone to thermal abrasion wear, as well as mechanical damage on bits, as you saw with the dole that I just pointed out. But anything less than 3,000 feet, you can see that the doles are typically 1-2 with chipped teeth, which is somewhat a precursor to broken teeth in some instances. But looking at what Ion Plus was able to achieve, that 8,493, and you take a look at that dole, that's a 1-2, and it went TD. So that's the type of step change in performance that we're looking at. And that 1-2 is it adds a lot to drilling economics, as far as directional control, wellbore conditioning, everything you can think of, that tool life, etc. As the bit stays sharper, it's just more efficient drilling, and it's more efficient all the way up the hole. So that's the type of step change. We're really excited about this run. This run was just 2 weeks ago, maybe even a week and a half ago. So we're very proud of this run, and we've seen a couple other runs follow it up, just very, very similar. So we're very excited about 2021 and Ion Plus, and this is not even considering shape technology.
Right. Yeah. So that's funny you mentioned that. So Prabhakaran, I know that there are folks like you and Richard who have real laser eyes, and that last graphic we had, they would have picked out that actually those bits were the Tectonic Pursuit series with the 3D cutters on them. So I'd like to maybe pivot over to you and just help folks understand, because I started out in the bits group, and I remember barely hearing about cutters, when they were coming out, and now you leave and all of a sudden they're talking about 3D cutters. So I just love to dive in a little more. What is it about 3D cutters that are really such huge performance drivers? Why is that?
Okay, it's a good choice of words you used, Michael. Performance drivers. It's good, really. But 3D cutters are shaped cutters, and there are 2 aspects why they become performance drivers, right? The first aspect is about the surface finish of the cutter, and friction plays a vital role in our lives in many ways. In one aspect, when the cutter is shaving the formation chip flows along the surface of the cutter, and that's when the friction comes to the picture, right? So there's a graphic over there showing how much the friction can reduce the force altogether. You could look at the graphics over there. In the lab tests we've done, several of them, it can reduce the friction forces as anywhere from up to 47% is illustrated, but it depends on the size and shape of the cutters again, right? That's one thing. And then there's another graphic that shows how the chip flows along the surface of the cutter, and when it's polished, it just slides along the cutter surface very effectively, reducing the force on it, net force on it. That's why you saw the drop in force altogether. And whereas when it's unpolished, it really becomes inefficient, and that's what we're talking about, right? Then that second aspect I was talking about 3D cutters is about the tip geometry, what we call in the question, the trivia, the chisel shape, the so-called 3D shape, and that's what it's about, right? So in this particular graphic, you will see how effectively it penetrates into the formation, brings about concentrated load into the formation, fractures the rock quicker, and releases the rock formation quicker. So what we're talking about drilling efficiency in terms of MSE, right? Industry uses the word MSE all the time. And what means lowering the weight on bit to get the same ROP, or getting higher ROP with a little highly increased weight on bit, or reducing the torque. So that's what this 3D cutters become so good. On top of it, right, we're going up. So if you look at one example, right, I'll talk about if you look at the we have got 3 types of 3D cutter offerings. There are 3 shapes different within 3D offering. That's a graphic showing 3 different shapes of graphic, right? So you have 3 cutters. They're all the same 3D, but they have 3D, 3DE, and 3DS. If you talk to our regional design engineers, they will make an offering and telling you what to use for the right application, right? And so how they affect this, if you look at this plot here, within this 3D family itself, they can bring about an improvement in ROP by another 10-15% by choosing the right shape within the 3D, and also help with the impact resistance of it. That's why we call it. I'll have one more example on the field run report, right? So this is a bit that uses all 3D cutters in the field, and it sets such a good record. And I'll have some details on the record in a minute. The next one, little slide shows this 3D shirt cutters on the bit, and you can see it, how they are shaped and they are placed on the bit. And the last one will show you how well it drilled all TD, and it drilled about, you can see its depth in at about 10,000 feet, drilled into about 1,300 feet. And the amazing part is the dull came out 0 result. So that's the reason why I say these 3D shaped cutters have become such performance drivers.
Right. So then a follow-up for you then would be, okay, if the 3D shaped cutters are such performance drivers, well, then I start thinking, okay, well, I could just design all kinds of shapes, but I know that you all have a very intentional approach to the designs that actually, ultimately make the cut. So can you talk about, what that vetting process looks like in terms of how you come up with those shapes?
I certainly can. So I have a little graphic illustration here, where in which we over the years, Reed Hycalog has invested significantly in testing capabilities, right? That's key to us. Just like Richard mentioned earlier, it's so important to understand the forensics of how cutter failures analysis to better cutter grade. We at the other end, the cutter shape group, we have to understand the fundamentals of how a cutter interacts with the formation while drilling. That's the key. And then we have, like I said, Reed Hycalog invested. We have a single cutter test system where we focus exclusively on how a single cutter interacts with the formation in terms of visualization and in terms of force measurements, and then also understanding how the chips are generated. And then we vetted out the right shaped cutter. Then we take it out to another level. We put it on the bit. We go to the bit rig, drill different formations, come about different from performance metrics, and then we come out select. Okay, this is the cutter that we want to take it out to the field, and then we want to run a field run just like that. That's what we do. So going on. So in the process, we've also come up after the 3D. We came up with the 4D shaped cutters, and that's another graphic I have on 4D where we shows the different shapes of 4D cutters, and how the chip flows. And on the 4D graphic, if you look at the 4D graphics, you see that 3 shapes on the 4D, right? It's one thing, if you pay attention to this graphics, it's so interesting. The shape is no longer planar. It's so complex. It's got one main cutting phase, and it's got 2 little side flanks right over there. And what happens is you look at the chip flow along this standard round cutter on the left-hand side, and then you look at the chip flow on the right-hand side, which is a 4D, how the chip is completely diverted away from the cutter face, reducing the friction on the cutter, and also getting off the cutters quicker from the virgin rock. And this enables improving the performance of the cutter 4D, right? And then there's one little plot. You see, okay, this is another thing that's very interesting. See how well the 4D cutters have quickly reduced further from the 3D aspects of it to bring about further drilling efficiencies in the field. We've noticed this in the lab, and we've also taken it to the field. And we've run several bits in the field with 4D shaped cutters. And this is one illustration where you see on the screen is a bit with 4D cutters now. It outperformed the 3D records that it had, and it also outperformed all the closest offsets that it beat its own record. It drilled better, longer, and the faster ROP, and also came out with a very encouraging dull. And that's what this bit's all about.
So, and I think it's really interesting, especially to your point, Prabhakaran, as you went through and showed, the impact that the shape can have. So I did want to then follow up with that. I mean, when I was in the drill bits group many years ago, I knew nothing about nothing kind of thing, right? But I do remember it seemed like the shape of the cutters was round, and you use them in almost every application. So as you look now at the either 3D or 4D series cutters, is that the same idea that you can use it across almost all drilling applications?
Yeah, well, first, Mike, I'll put you on the spot, ask you, how many types of knives do you have in your kitchen drawer at home?
Let's see, 1, 2, 3, 4. I've got north of probably 11 or 12.
You see, that kind of that's where I'm going right now, right?
Okay.
See, I have different knives to cut different kind of, knife to cut for the meat, I've got a knife for the vegetables, I got things like that, right?
Right.
It's all about efficiency, right? When you get to the level. And that's the kind of communication we're bringing to our customers also. So we can use one shaped cutter, and there's a graphic that shows right there. I mean, it's right there. We can use one shaped cutter, and that's been in practice for over the years. But now, if you look at what we have offered, we have about 6 to 8 different types of shaped cutters for different niche applications. Every formation fails differently. Every formation has different strength, and that's what we are trying to bring about and share this information with the customers and say. So if I go to the next graphic presentation I have, this is an interesting test we did in the laboratory. So where, if you pay attention, we had 4 different cutters. What we did is we started off the round standard cutter, ran it into sandstone, salt, shale, and limestones formation, and we established a benchmark, and that's what the white little rhombus shaped or diagonal shaped diamond shaped, right? Then when we took out the round cutters and put in 3D cutters and ran the same set of parameters and drilled the formations again, and we see a bump in ROP in terms of performance, right? So the same weight on bit in shale, salt, limestone, and sandstone, and not so much in shale. Then we go back, change it out to a 4D shaped cutter, and we say, wow, we see a big jump in all the formations again. And then we go back and apply 4DC. 4DC also shows another big jump in so much in shale also, and also in salt. So that's what I'm going to with knife technology and things. It's up to us to make decisions to use the right shape and leverage the efficiency. Otherwise, we're taking a lot away from the table when we go with the same shape cutter all along. And that's where the technology is coming to us. We are going to have more and more shape cutters going in the direct direction right there. Right. Again, like I said, then we have I have another exhibit right there where we've adapted how to mix and match different shape cutters into a bit configuration. One we call a saber tooth, and then we call a chainsaw. We're using all shape cutters, whether it's a 3D or a 4DXC, or in the saber tooth, we use all round and a change like that. So between those two, we have made a lot of world records, a very good performance, and help the drilling efficiency to our customers. And this is the information we want to share with you all again.
So I'm not asking you to, pull back the curtain. I don't want Richard to jump through the screen and tackle you here, but can you tell me a little bit about what's kind of coming down the line, or at least maybe even give us a little hint? Because I know you all are nonstop, innovating and developing and talking with customers and trying to find things that are bleeding edge. So to the degree that you can share with us, what's on the horizon?
Okay, I have one little thing I can share with you all, right? But there's a lot of works we're going on, but I'll quickly I'll summarize one thing. There's one shape cutter called the 5D shape cutter that we are really working on. And it's basically more towards the hard rock drilling formations. And we come up with this particular shape, and it's shown very good promise in the lab, and it's also in the field, a few runs in the field, how they can withstand higher impact resistance. And that's where we're working, one of the things that we're working on. Another thing we're working on is the high frequency torsional oscillations that's been kind of terrorizing the drilling industry, and thinking how we can mitigate this high frequency torsional oscillations. And we're coming up with cutters shapes, and also with bit design, we'll combine it with different cutter shapes, and that will help going forward, trying to do that. So 2 things. Yeah. That's where I am.
All right. I'm being told don't say any more. So don't. Yeah. No, but that's great. That's really good. So Richard, based on the conversation we've had, both from you and Prabhakaran, it sounds like there's a lot of really good stuff coming down the pike. So, I mean, my thought is, as we're looking, is there anything else that you wanted to share, or anything else that we can be looking ahead towards?
No, I mentioned the cutter development is a very rapid area within drill bits industry. So, the things that we have launched, like Ion Plus, we recently launched it out. We want our customers to take advantage of that technology. I mean, you saw the performance gain that was shown here today. And that's what we want to help our customers with, the improved performance and the drilling economics. So we look forward to also combining the Ion Plus with other shapes and lead our customers to better drilling economics. So we also have a lot of new marketing material, and then also technical marketing material where customers can actually go to NOV and a website and learn a lot about this technology that we talked about today in a little bit more detail. And also there's an area there so you can reach out and contact your local sales teams as well, and read Hycalog's sales team and get some more information directly from a person. So that's
okay.
Yeah.
And what's that website for folks?
It is NOV.
I think it's.
Sorry.
Do we have? Oh, there it is. Okay, I was like, I know we have it.
Yeah.
Okay.
Sorry.
Yeah. So was that NOV.com/Ion Plus? So you all have loaded that up and ready to go for folks to find more information and reach out. So that's great. Well, I tell you, speaking of reaching out, I've been enjoying our conversation. Just been glancing over a little bit, and I've seen these questions really starting to pop in. So. We're going to get Shelby in here in just a second. But if you're watching either at home, at work, or at your homework, feel free. If you have a question for Richard or Prabhakaran that maybe piqued your interest that you'd like to ask, go ahead and type it in now. We're going to start getting those questions answered now. But you can fill that in whether you're watching us on LinkedIn, Facebook, or YouTube, and we will try to get to your question in today's program if we can. So while some of you might be typing, I know that Shelby has certainly been collating those questions. So we're going to go ahead and bring her in and start those questions rolling.
Absolutely. Oops, sorry, something got in my eye. So the first question we have is, what is the future of drill bit technology? So we're starting off with a big one, but that's what we got from LinkedIn. What is the future of drill bit technology?
Rachel.
Yeah. So I can take some guesses. There's some things that I can't say as well, but one of the big things is making a smart drill bit where you can measure dynamics downhole at the bit, because you can understand that would help cutter life. If you know how bits are dynamically moving downhole and what are the actual impacts or toughness that's needed for cutters, and how the life expectancy or I would say how the life of the cutter reacts to downhole events. So that's one thing. Another thing is kind of mentioned cutter forensics. It's very critical to the development process as well as to just cutter selection, and it's a huge win. It's almost like low-hanging fruit. There's been a paradigm shift in the drill bit industry where our customers are seeing the importance of this data set, this cutter forensic data set, and they're requesting drill bit companies to automate this process, and that's another way forward, so that you can get vast amount of data about every single bit, and then turn that into development work so that you can improve your performance, and that's a huge win for drill bit companies and our customers alike. So those two things I think are the biggest things that are probably happening the fastest. I think that's going to be the hot two things. The other one is high frequency torsional oscillation that Prabhakaran brought up earlier. That's another area of importance that we see there's focus, and that also goes along with recording downhole what happens to drill bits while they're downhole. Lastly, I would say shape cutter technologies it has exploded within the last year, and you've seen that same trend over the last 6 years since we introduced 3D cutters to the market, and other shape cutters have been coming to the market. So we think we're going to see that continue. That trend's definitely going to continue, and each drill bit company is going to have their overall philosophy of how they implement that strategy. And we have our strategy, and we're very proud of it, and we're benefiting from all the performance gains that we've been able to pioneer over the last 6 years, right? Which we've probably I would say we're one of the first few that were able to get commercialized shape cutters around the globe, and we're proud of that, and we're going to continue that effort.
Mm-hmm. Excellent. And we also had a question on LinkedIn from Dawn, and it was about kind of in the climate change, energy transition conversation. And so I wanted to ask, because I know one of the benefits of these drill bits is that they perform really well in a lot of those harsh, hard rock environments of geothermal drilling. Could you talk a little bit about the bits in that geothermal space?
Yeah, absolutely. I think one of the examples that Prabhakaran had was actually from a geothermal application. I know we didn't touch on that in detail, but the 40XC cutter was very critical in that application. First, we tested a cutter grade, which is the foundation of durability, right? So in a full round cutter, where you get your cutter grade right, then you have something to work with, and then you apply the shape cutter to it, and with that we were able to see a significant increase in performance for our drill bit. So yes, what was once not economical was traditionally a roller cone market due to the harsh environment, and also that cutters couldn't hold up. The cutters are holding up now, and are basically the way forward. So PDC cutters is again encroaching more and more on roller cone market and becoming more economically feasible. So we have several case studies in different areas of geothermal applications, from New Zealand to the United States, and some of this data is within the last few months. So these case studies. So we're actually very proud of that as well. So we're attacking all the different markets, and we're seeing our technology do well in those markets.
Which I think is really interesting and a great testament to the versatility of the technology, right? So those that are utilizing these drill bits can use them in a traditional, oil and gas space, or potentially, depending on the application, use it in an emerging, geothermal space. So it's just really interesting to be able to see that evolution and how that's able to be used.
And the economics of it too are getting better, because they're seeing that you don't need to necessarily go too economical and then limit yourself on performance.
Right.
So now you're saying, okay, I'm gonna buy the better performance, but then it saves you so much money in the back end.
Right.
So it's incredible. It's going to be a shift.
Yeah. Thank you.
Really the best of both worlds there.
That's true.
So this next question, I'm actually going to pull it on screen because it's a little bit longer, but I think it's a really great question. It comes from Ajay on LinkedIn, and he's wondering, how does the impact resistance and durability of these cutters compare to traditional round cutters, and how do you ensure impact and durability is maintained and improved with the new shapes?
Okay, Richard, you want to take a shot, or you want me to go over there?
Well, let me just give you one aspect there. There's an S for each different shape. It's different, right? You're going to have to prove it out for the specific shape. For the 3D, there's an SPE paper about it, and it was actually written by Reza Rahmani and Tom Roberts and Paul Pastusek, which is one of our customers. And they tested how strong and robust the 3D is compared to a full round cutter. And the surprising fact was that the 3D held up in really high compressive strength rock. I think it went up to plus 50,000 kpsi. So it was very impressive that the 3Ds held up where the full rounds didn't. And that comes to the cutter rock interaction, where the shape of the cutters actually fell in the rock before the rock fells the cutter. And it was very interesting. So I'll just touch on that, and then Prabhakaran can talk about the testing and the details.
Thanks, Richard. I mean, that's a fact, right? Real fact, what you just revealed, right? I mean, it's engineering, right? The question always goes back. We've had different materials like aluminum, steel, and then we can have different designs. It's about so cutter grades have changed drastically and helped us do shaped cutters. That's the important pattern. We got to remember that. So people ask the question, hey, it's shaped V and it won't have produced the same ROP because it's removing lesser material. That's not exactly the fact. Because we go back to the lab test and we go back to the field runs, we are generating higher ROP. We are encountering higher forces with the same, with a shaped cutter as compared to a round cutter. So that is a testament by itself, right? So yeah, the grades is a part of the material and how the grades have evolved over the years, how PDC grades have been manufactured. And that's the aspect we're taking advantage and now shaping it. Couple, like Richard said many times, we're coupling the shape to the grade, and that's where we're leveraging this the strength. It's important that aspect has to be very good. That's how it is.
So just to close on that, there's single cutter testing, for the grades alone to test the different indices, strength, toughness, and abrasion resistant, thermal resistant. Then on the same thing for the shape cutters, go through the same regimen. They also go through a pre-cut, as you saw on the screen, testing apparatus, and that shows the efficiency. And then back to the durability and efficiency, we also drill using full drill bits on our performance, our pressurized drilling lab. So that also gives us another aspect of how well the cutter is going to handle weight. And that's actually part of the SPE paper of how the program of testing went. Well, maybe we can post the SPE paper number and it would answer that question a little bit better. Yeah. Mm-hmm. I hate to keep on going, but it's so we got so much information. It's almost hard to not, right? So we also had a big stream of lab data, right, from the lab that paper that's included in that paper. But we also have field studies where we actually correlated 3Ds compared to full rounds over a 2-year time span. And seeing the difference in the doles, same application, same parameters, comparing apples to apples, and over that time frame, the 3Ds chisel has outperformed full rounds, and that's again, the shape of the cutter is going to fail the rock versus the rock failing the cutter. It's traditionally thought.
Absolutely. And never apologize for too much info. If I've learned anything from being on the social media here at NOV, it's that our audience, we love field test studies. We love all of that information. So never apologize.
So we'll get those SPE papers posted. I was actually one of
That's a good idea. That's a good idea. Yeah, that's a good idea, Richard. Yeah.
Absolutely. Well, I'm going to ask this next question from Larry on LinkedIn, and I'm going to put it up on the screen again. He asked, with the new hybrid bit matrix designs in the market, how will 40 cutters change the marketplace in ROB and ROI?
So, okay. How will hybrid bit matrix designs in the market? How will 40 cutters? It will change, right? But keep in mind, 40 cutters, when we saw what I in one of my graphics displayed, just showing how it can reduce the torque as well as it can reduce the effective weight on transformation into the formation to fail. So that's the key. The efficiency is all about reducing the MSC. So with hybrid, it can help contribute in terms of reducing the torque significantly when it's put on motor or it's on a straight vertical drive. That's fine. But I think that's where it's going, and reducing the effective, how it can reduce breaking the rock quicker and also reduce the torque on the bit.
Yeah. I think another aspect there is when you talk about hybrid matrix bits, and I'm assuming you're talking about fuse tech, right? So you have high ROP, low depth of cut type of scenarios. The cutter grades themselves are going to help as they improve, but also the 4D. So one of the pictures that you may not have seen was that the 4D is actually provides stress concentration in front of the rock. Or in front of the cutter, interacting with the rock in front of the cutter, and that alone is going to provide the better efficiency. And if you move to something like a 3D chisel, and in these hard applications where we're seeing that the 3D chisel is actually working, and you add that to the 4D family with the plowing in front, it's just going to add more efficiency. So as the cutter grades get better, these potential hybrid matrix bits may start to reduce the usage, and you may not need the hybrid in certain applications. We don't know how far that's going to go, but we have seen that happen. So it's a really good question, and it goes to it's good thought process to almost kind of ask a question about what we've already seen happening. So interesting.
And a quick add-on to that is, it's also the reverse. It's lesser force back on the cutter face also. So the longevity of the cutter is going to be improved also. So that's what you've seen in the dells. That's another aspect.
Mm-hmm. Absolutely. And I think just for the sake of time, we'll close it out with one more question. But Dustin on LinkedIn, he asked, could you spend just a little bit of time talking about 3D edge geometry and where it is being applied?
All right. Okay. Yeah. So it depends on, again, when you go and talk to our regional design engineering team, they'll come back and say, okay, when they see a huge benefit of when bits come back with almost 0 dull, right? When you use a regular traditional 3D cutter and bits come back 0 dull, and you've already seen an improved performance on that. But that's when hey, we can push the limit. The 3D edge is about having a sharper edge over there. That means we can take a little bit of hit on the cutters, but also improve the ROP significantly, right? That's the benefit of using the 3D edge, or the 3DS, right? And then when you have impact, and also the same thing with the impact resistance. When you want the same performance, but also want to make sure you want to safeguard it against some impact damage, and that's when you use the 3D edge also. They can use those kind of things like that. Justin, you want to add something to that, Richard?
Yeah, I would say that these are newer designs of 3Ds. So we have cutters in the field being tested. Our lab data is complete, so we're waiting on some of the field tests to come back and give us an idea. We have a good idea of how they're going to perform and that they are going to do well, just as Prabhakaran mentioned, in those types of applications where you're just trying to get that ROP. So we're on pins and needles waiting for the field results to come back. What we know is that the edge is something that we've ran in the past on full round cutters, and they provide an increase in ROP. So putting them on shaped cutters is no different from what we already know. So we're excited about that. Now the 3DS, which is another version of 3D, was actually adding efficiency from having a sharper tip profile. That cutter we do know has improved ROP. So the next iteration naturally is 3D-SE, right? Once we prove out 3D-E works. So we're kind of looking forward to seeing what those cutters result in as far as performance goes.
All right. Wow. Well, I was. I'm always excited when you all can have all the answers. I always wonder maybe you'll get stumped, but you guys came prepared, and certainly the technology and the cutter design, geometry, and really a lot of the R&D efforts that you all put in certainly show themselves and have proven them out. So, Richard, Prabhakaran, I appreciate you taking the time to join us and share insight on the Ion Plus cutter technology today.
Yeah,
thank you so much.
Thank you.
Thank you so much, Michael, for having us. And
thank you.
Thanks.
All right. And so we appreciate everyone joining us. Of course, we're going to get to Shelby Dumaine to get the answer to today's Rig Geek Post of the Week, which based on a lot of the Q&A today, I would not be surprised if we had some really great answers from our viewers today.
Absolutely, we did. And we're going to show that question again one more time before we answer it. But we asked, what year was the Ion 3D chisel cutter first introduced by Reed Heikelog? And as far as answers, we got stuff from 2007, 2017, and the answer actually lies somewhere in the middle there in 2015.
Okay.
Is when the first Ion chisel cutter came out. And I do have a little bit more. So I actually have the serial number for those rig geeks. If you really want to,
that's a real rig geek. They want serial numbers. I just don't want a year. I want a serial number.
Hey, that's right. I know our rig geeks. I know how they are.
Yeah.
So that serial number we have, it's actually the E219369, and it came out in Oman on October 23rd, 2015, to be exact.
Bingo. Yeah. That's great. Wow, man, that was a good one. I'll give a hat tip. So, well, great. Well, I appreciate that, Shelby. That was a really great Rig Geek, and I think a really great Q&A that we had today. So appreciate all of the folks joining us today, and thank you for joining us. And as always, if for whatever reason you stumble upon our post today or you weren't able to make it, don't worry. You can watch all of our previous lives on our website, and that'll be NOV.com/live. And there you can watch all previous conversations. And again, as part of today's conversation, if you want to go directly and find more information on the Ion Plus technology, you can head over to NOV.com/Ion Plus. So for all of us here at NOV, thanks for joining us, for watching, and for listening. And we'll talk to you again next time.